Welcome. In this session, we are going to understand union find data structures in Java. As you have already understood union find data structure in previous session, union find disjoint set data structure is used to model a collection of disjoint set which is able to efficiently determine which set an item belongs to, test if two items belong to the same set, and union two disjoint set into one when needed. It can be used to find connected components in an undirected graph and can hence be used as a part of Kruskal minimum spanning tree algorithm. Here for an example, we have two disjoint set available in which rank of both the disjoint set is 3. They have individual set of elements available, and here we can see that 7 and 6 belong to same subset and 15 and 14 belong to same subset. Now we are going to get started with a sample example in Java. We are going to initialize 10 elements, and as soon as we initialize 10 elements, you can see that this complete structure is a union find data structure. Within this union find data structure, we have 10 subset available. Individual set size of every subset is 1 at the moment, and rank of every individual subset is 0. Now we are going to get started with the program in Java. Here we'll proceed to our Java program, wherein we have created a new Java project known as search find. Within source directory, we are going to create a new class. First class will be used to test. We are going to make use of test union find class. Within this, we are going to have a main method which is going to perform test, wherein we are going to make use of functions which are available in our union find data structure. So we are going to have public static void main string arguments, and now here what we are going to do, here we are going to test the functions. Within the default package, we are going to create another class, and this class will be our data structure union find. You can see that we have created a data structure union find, and within this data structure now we like to get started with basic private variables and functions which we want to create. First of all, I would like to create some private vectors, and these vectors will be integer vectors, and first will be p, which will hold my union find data structure. Then we'll have rank vector in order to keep track of rank. Then we'll have set size, which is going to handle set size of every individual subset which we have in our union find data structure. We can use control1 to auto import vector from the class java.util.vector. We're going to have a private integer which is going to define number of unique subsets or disjoint sets available in our data structure. Now once we have this, we already know that union find data structure has two important functions. One is to find the set, second is to merge the set, or you can say union the set. So first of all, we like to get started with a function, or we can also say a method, which is going to construct our union find data structure first. So we are going to have a public union find constructor. This constructor is going to receive n number of elements which we like to create. Let's say n number of elements will be provided to our union find data structure, and values will be set. So now what we like to do, first of all, we like to create the rank element. So we are going to use rank.set, and rank.set will be a new vector. Let's just initialize the vector first. So we are going to have an integer vector with size n. So rank has been created. So we are going to have every individual rank. Let's say we are going to have the number of sets, because rank will be 0 at the moment. So set size, and first of all we should have p. So we'll have n ranks available. Then what we need, actually we need p elements as well. So let's get a vector integer wherein we are going to have n number of elements within our union find data structure as well. Then we have set size. We are going to initialize set size. So we are going to have individual number of set size. We are going to compute value of set size for every individual n elements which we have. Later we have these information. Now what we need to do is, first of all, we like to add the values into set size. So we are going to create a for loop in which we are going to keep the sets. So once we start, the number of sets will be n. So since we have an integer value, n subsets will be there as soon as the data structure will be initialized. Then we are going to have a for loop in which we are going to get started with 0, integer I is equal to 0, and now I should be smaller than n, and we are going to increment I until and unless we reach n. Now we like to add elements, so we like to add an element. Let's say we like to add an element I within this P, so 0, 1, 2, 3, 4, 5 will be added. Now what next we'll have, once we have added this, we like to add rank of the element. So once we create the structure, rank for every individual element will be 0 by default. So let's say we are going to add 0 for every individual elements for 0, 1, 2, 3, 4, 5, and let's say we are going to have a set size. So set size will be 1 by default for every individual element. So let's say we are going to add set size as. So now our union find data structure has been created. Now what next we like to do, once we are ready with the constructor, now we have to proceed to different functions which we need. So the very first function we like to create in our method will be a find set. So we are going to return an integer value, and we are going to create a function find set, and with this find set we are going to receive an element, let's say I, which we need to find within our element, and finally we are going to return a value. So let's say before returning the value we can simply check that if an element is available, then we are going to return. So since we already know if ith position of union find data structure contains the element and it's equal to I, then we are going to return I. So let's say we are going to check if, let's say if our p dot get of ith element is equal to I, which has been provided as an integer. In this case we are going to return I, and if that value is not true, else what we are going to do, if this is not true, then we are going to compute, we are going to find the set for p dot get of I. We are going to find this, and we are going to store this value into an integer value, let's call it as return value. So we are going to receive that value. In case now we are going to check if that value is not available, we are going to replace the value of ith and we are going to return the value of RET. Let's say we are going to return the RET, and we are going to check whether we are going to set the value of p dot set of ith value will be set as my return value. So now with this, first of all we are going to find the element, and this is same as equivalent to the C code which we have written in the previous session. So once we have found out whether a set is available within our union find structure or not, then we are going to proceed with different examples, like we are going to execute the union set, then we are going to find the number of disjoint set, we are going to get the set size and something. So before proceeding to this, let's write a basic function within our public static void main. So now what we like to do, first of all we like to create a new union find structure. Let's say we are going to create a new union find, and we are going to supply, let's say 10 within this union find structure, and we are going to call it as uf is equal to new union find, and we like to create the local variable uf. So using this, our union find data structure will be initialized, and now once we have got this union find data structure initialized, we like to find a set which has been created. So let's say we like to do something like system.out.println, and let's say we are going to say 2 is in the subset or is in uf. So we are going to find the set, we are going to concatenate uf dot find set, and we are going to specify the value of 2, so that will be printed. So now once we have got this, we are going to save the code, we are going to save all the codes which we have written, and we like to run the application. Once we execute and run the application, we are going to see that yes, 2 exists within this application. So 2 has been found out. Let's say in case if we want to test any value somewhat like 5, whether 5 exists within this, so we are going to save it and we are going to run that. Once we run that, you can see that 5 also exists within this. In case if you want to replace that with something like 11, we are going to replace the value 11 and we are going to test how it reacts. So it says that since it's not available, we are going to get the exception that this token is not available. So this is how we can specify specific information. In case if you want to put that into try catch block, you can simply put that into try catch or something, and you can specifically specify exception E, and we can simply specify something like system.out.println, and we like to say something like the current element which has been specified doesn't exist within your code. Let's say we are going to specify 11 does not exist. So something like this. Let's say we are going to execute and run. So this time you will say 11 doesn't exist, but in case if you have specified somewhat like 5 and you are searching for 5 within your union find data structure, as soon as you run, you will get that 5 exists within the structure. So now what we have got this structure created, and now once we have executed find set, now we are going to check whether both the sets exist in the same set or not. So we like to create another method within our union find data structure, and this method will be our boolean method. So that's going to be a public boolean method, and this is going to be known as is same set, and we like to check two elements, integer I and integer j, and we like to check whether both of this I and j belongs to same subset or not. So we are going to execute a return statement, and we are going to find set, and we are going to find the set I, and we are going to check if it's equal to find set of j, and if both are equal to each other, we are going to return the statement. So we have to specify the boolean value. Let's call it as boolean. So we are going to return this value. So now let's just save it and test the code. In order to test, we like to see whether both exists in the same set or not. So we like to execute some statements like just after the catch. Within this statement, we can simply test that. So what we can do is, let's say we are going to test whether uf dot is same set exists. So let's say we like to check if 3 and 4 exists within the same subset or not, and we like to execute system.out.println, and we like to check 2 and 3 exists in same set or not. So we like to execute that statement here, and once we do that, once the code gets executed, either we are going to get a true result or a false result. So once we run that, we can get that 2 and 3 exist in same set is false, because we haven't joined the set at the moment. So now what next we like to do, we like to write a method in order to merge our union. So this time we are going to return public void union set function. Within this we are going to receive two values, integer I and j, and now once we have received this, we are going to union to specific set. So now first of all we'll check if both are not in same set, only then we are going to join that. So we are going to check if not is same set, we are going to make use of the function is same set, and we are going to specify I and j. So if it's not true, only then we are going to execute the code. And now what we are going to do, first of all we are going to decrement the number of sets which we already have. So we are going to replace number of sets minus minus. So that means one set will be reduced as soon as a new subset is formed. Once we did this, now we need to check the rank wise compression or union. So now we like to check if, now we need to check if rank.get, and we are going to get the rank of I. Let's say before this we should get elements for x and y. So what we like to do, before this we like to find the set whether the input provided values are available in the union find data structure or not. So let's say we are going to take a value x and we are going to find set, we are going to supply I. If this exists, and we are going to take y variable and we are going to find the set whether j exists. If both of these values are available, now we are going to compute rank. So in order to do this, we are going to check rank.get, and within this rank, first of all, we like to check for x, and we are going to check if rank dot x is greater than rank of y. Then we are going to execute some codes. So here we are going to compute if x is greater than y. Then in this case, first of all, we need to replace the value of y, and we have to introduce that into subset of x. So for this, what we have to do is, let's say we are going to change, we are going to get the element of, we are going to increase the size and rank both. Now we are going to replace the yth position. Let's say we are going to get the, we are going to set the value of yth position to x in case if rank of x is greater than rank of y, and then we need to increase the set size. So we are going to perform set size dot set, and we are going to perform the set size of x. We are going to increment that to x plus y set size. So we like to perform set size dot get. We like to get that for x, then we like to get the size for y dot y, and now both will be added and will be stored into the x value. And if the rank is smaller, then what next we are going to do? If rank is smaller, then what we'll do, we are going to set p dot set y position, x position will be set for y, that means y will be root at the moment. And once y will be root at the moment, then we are going to execute set size dot set, and we are going to change the rank and set size of y element, and that will be set size dot get of x plus y. We are going to set that set size dot get for y. So rank of y will be increased at this moment, and if both ranks are equal, we are going to perform another check here. If rank of both, that means if rank of x, let's say if rank dot get of x is equal to rank dot get of y, so in case if both are equal, then we are going to improve the rank dot set for y, and that will be, let's say, rank dot get of y, and we are going to increase the rank by 1. So now this is how your union set will be performed, and once union set is performed, then we can specifically compute the number of disjoint sets and number of set size which is available. So now what we have is, once we have performed the union set, now we like to perform two more functions, and this function will be integer function. We like to create one more integer function, and this will be number of disjoint sets, let's say number of subsets, we are going to call it somewhat like this, number of subsets, and for number of subsets will return us a value of number of sets which we have created at the top. So this value will be returned back, and finally we are going to uniquely specify set size. So let's say we are going to get set size for an individual set element. Let's say we are going to provide that for I, and then we are going to return a value, return the value, and we like to get the element of, we are going to get the element of p dot get of I. So we are going to set the size dot get, and we like to p dot get and the element which is provided. So this is how we are going to get the size of the element as well. So here we have created our union find data structure in Java. Now we like to perform execution. So we'll go to test union find, and once we did that, now we like to perform union on this. So we'll perform uf dot union set, and we like to add 3, 4, let's say. So once union has been done, now we like to check whether 2, 3 and 4 exist in the same set or not. Control V, let's say this was 3 and 4, and let's say 4 and 3 is in same subset or not will be checked. And once we have performed that check, now we like to specify system.out.println, and we like to print with the number of sets, number of disjoint sets, will be, we like to concatenate that with UF will be the object, and within this we are going to get the number of subsets. So we are going to execute the method number of subsets, and then we like to print the set size. So set size for 3 is, we like to get the set size, so we are going to execute dot get set size, and we are going to pass in value of 3, and we like to compute. So once we have saved, we like to run this application. In order to run, we can simply proceed to run test union find, and as soon as we execute, now let's say we have got the result that yes, 5 is in union find data set, 4 and 3 exist in same subset was false, but once union set has been done and then we have searched that 4 and 3 exist in the same set, number of disjoint sets has been reduced to 1, reduced -1, and hence from 10 it becomes 9, and set size for 3 is 2 because we have added some elements. So now what next is, we can execute more union sets. Let's say I would like to perform union set of 3 to let's say we like to add 6 as well. So once we did that and we execute this application, now you can see that 4 and 3 exist, number of disjoint set has been reduced by 1 number more, and now we have only 8 disjoint sets, and set size for 3 is 3 elements because we now have 3, 4 and 6 available in the same union find data structure. So this is how we can create union find data structure, and the things which we have done here, I would like to animate that. So let's say we have identified 3 has been available within the element. Now we like to check whether 3 and 4 were in the same subset or not. So we did that 3 and 4. So both will be pointed at the moment, and you can see that 3 and 4 both are not in the same subset. Now what next we like to do? We like to perform union set. So we like to specify 3 and 4. Once we did 3 and 4, so both will be added. Why 3 will be added as the 4th element. Now 4 has rank 1 and 3 is somewhat like this. And now in case if we want to perform 3 and 4, let's say we'll check 3 and 4 whether they both belong to same subset or not. As soon as we click on go, you can see that both elements are available within the same subset at the moment. So this is how you can create union find disjoint set data structures in Java. Thank you for watching.